At its heart, Erda Deep is a coaxial borehole developed to serve high energy use intensity applications within the complex spatial, geological and operational demands of our new and existing building stock. Erda Deep starts with desktop analysis, no need for on-site thermal response testing. Our robust borehole design, combined with Erda Sim, our in-house simulation tool, enables accurate prediction of the ground's thermal response to dynamic building demands. Erda Deep has been successfully deployed in a wide range of geological settings, including clays, chalk, fractured rock, aquifers and artesian conditions, where conventional YouTube systems are often unsuitable. This gives us confidence in performance without the need for intrusive testing. It's closed loop, so in exchanging energy with the Earth, no fluid enters or leaves the system, and the coaxial design confers a number of benefits to the application of geo-exchange. The highest amount of energy exchange surface available from a cylindrically drilled hole, radiating energy in true 360-degree fashion. The working fluid passes through Erda Deep in a relatively well-insulated inner tube to the bottom of the construction. At that point, it returns to surface via the annulus. Erda Deep is primarily of steel construction, which is thermally a highly effective interface between the working fluid and the various geological settings it passes through. Erda Deep can be sized for any length or depth, but is typically between 150 to 400 meters long, and is dependent on the needs of the application. Heating dominated, we want to go deeper to access higher geothermal temperatures. Cooling dominated, and we might want to stay in the relatively shallow geology. Either way, well below the influence of seasonal weather and temperature changes into a stable and predictable temperature environment. Given that primary energy exchange is achieved at the bottom of the Erda Deep borehole, we need to ensure each one is suitably separated to maintain thermal independence from any neighbouring borehole. Because Erda Deep is thermally so effective, separation is typically 16 meters as a minimum. Erda Sim can be used to simulate 10, 20, 30 years of operation to ensure performance can be relied upon across a realistic time frame within the built environment. The required separation at the bottom can be achieved using a combination of vertical and inclined drilling techniques. This technique is particularly suited to dense urban environments where available space at surface is limited. And Erda Deep can even pass safely beneath existing structures without impacting, allowing Erda Deep to access the full geothermal potential of any site. Once installed, the surface can return to its prior use, or even a new use with minimal disruption, keeping business as usual intact. The result? Significantly more energy per Erda Deep borehole. Fewer boreholes needed, smaller footprint. The configuration of Erda Deep is always bespoke, precisely tailored to the building's energy demand, geological conditions beneath site, and available space logistical constraints. Tangible examples. Oldham. A large supermarket heating and refrigeration load was met using 6 Erda Deep boreholes installed in an area equivalent to a single family car. An estimated 99% reduction in surface area compared to a conventional YouTube system. Keeping space as clear as possible and without disrupting the normal operation of a fast-paced food retail setting. Sheffield. During simultaneous construction, ED was installed in a long, narrow array along the road edge, maintaining access to the rear of the site. Both the client's and Erda's projects were able to progress with only minimal disruption. With Erda Deep, the primary energy source is located beneath the site itself. This reduces exposure to external fuel supply chains and market volatility. The system provides a consistent and predictable source of thermal energy, independent of imported gas or grid constraints.